Hello, everyone. My name is Do-Kyun Kim, currently working with the Department of the Naval Architecture and Ocean Engineering at Seoul National University. Today, I'm going to introduce about my research group, Ocean and Shore Technology, and we call the OST, but it doesn't mean that the original soundtrack. It might be better for you to remember. So at the same time, we'd like to motivate all of you guys like talented young researchers. So let's get started. So this is overview my presentation and the 5 minutes the introduction of the OST, followed by the existing and the future research work about 5 minutes, and we are going to have a 5 minutes Q&A session. That's all. And we established in 2015 when I was working in Malaysia. With the Petronas University of Technology, and you can see that all the members at that time. And after that, I moved to the Newcastle University in 2019, and recently I moved again to the Seoul National University. So this is our, research group OST, and Ocean and Shore Technology, especially here, shore represent the onshore, offshore, and the nearshore. We has prepared a variety of the specific and the realistic problems and the programs to provide the practical values for the future talented researchers like you guys. So we provide the researchers with excellent environment, humans, and networks, and services and opportunities to produce the future leaders. So this is our vision and missions. So we'd like to become a world-class research group, and we want to provide the creative ideas and develop the knowledge and contribute to industry and the social advancement for young talented researchers, and missions to develop and expand innovative research capabilities and provide young talented researchers. At the same time, we'd like to collaborate with the other top-level research institutes. So this is the main slide, and actually it looks quite complicated, but what we are doing is you can see here the right-hand side, top right, you can see the damage structures like the explosion, fire, grounding. Some of the vessels are broken into two pieces. So what we are doing is non-linear structure mechanics-based structure condition assessment. So limit state design, for example, the ultimate strength and fatigue limit, accident, something like that, and condition assessment of the aged structures. Of course, as time goes by, our structure or our human body will be aged, and the buckling and the Arctic conditions, LNG, nowadays we are talking about the renewable or the hydrogen energy like that, and accidental damage assessment. So this is our human body. All the photos in this slide captured by the Kusori, and the human bodies and our structures are quite similar. What I'm talking about is when we construct our vessel, that is like the as-built condition to a newborn baby. And as time goes by, of course, we need some kind of inspection like the X-ray or something like that. And after that, once we detect that something goes wrong, then we need to take action. So after condition assessment, like medication, operation, maintenance, repairing, like that. So what we are doing is actually summarized here. So this is our collaborators. I was working with the Newcastle University and the Petronas, UCL, and the MPNU, and the Tsinghua, something like that. So existing and future work, this might be interesting. So visualized result, and of course, this is also captured by the Kusori, but I was also the member of Kusori at that time. So I was working on the aged related like the corrosion, fatigue, cracking, denting. And once we, construct the vessel, of course, there should be initial imperfections. And during the operation, we need to consider the abnormal wave, environmental conditions, dynamic pressures, sometimes the low temperature issues, cryogenic, ultra high pressure, or this accidental condition is the fire and explosion. Actually, those two are the one set, and impact load like collision, grounding, and drop object. And recently our group slightly shift to this way. But you can see here, I don't want to explain all the details like the IoT, IoE, but what we know is the data connection is truly important and it's like the clouding system. So once we gather all the data, the shape will be like the big data. So once it goes heavier, then we need to do some kind of processing. We call it data processing. So conventionally, we also did it like a conventional method is available, but at the same time, nowadays, we are always talking about the artificial intelligence, reinforced learning, machine learning, deep learning, ANN, DNN, like that. But what we are doing here is the proposal is actually the data optimization. And for what? Engineering. So basically, we try to gather some data using the finite element method or the sensor, and the data processing might be utilized by the conventional or the AI techniques. And at the end, we want to apply all the things, optimize data set for our engineering design and manufacturing. So that is the thing. And this is the example. You can see here Pipe Alpha or the Deepwater Horizon accident almost 11 years ago by the BP. And top right, you can see the offshore oil and gas production systems. And we have to install the blast wall to protect our human life. So this is the FEM, the modeling. And after that, you can see here, this is the actual testing. You can see it is huge amount of the blast load applied to the structures. So how are we gonna protect our structure? That is one of the way is install the blast wall. So we try to, model the sandwich panel system. We call the SBS, and the core, the shape is like the hexagonal. So we try to do some kind of the data processing, as well as we modeled the 450 finite element models. And after that, this is some kind of examples. And we did data processing. We could be able to provide the design formulations. Or here, this vessel is broken into two. And basically, this can also be modeled by the FEM. And it should be subjected to the vertical bending moment, and backside will be compressed or tensioned continuously. And this deck is combination of the plate and the stiffness. So this is the final element analysis result after we apply the progressive collapse load. And you can see here the buckle or the ultimate limit state. And this is the stress strain curve. We call the load shortening curve. And after that, we conducted data processing, and our group could be able to provide the design formulations. We call the empirical formulations like that. But here, important thing is not what is not important, or the how is not important, but the most important thing is why, or the question mark. Why we need to do this? We want to provide the easy and clear design formulations, the design solutions for our customers. So here, this is the outcome. You can see we developed our own data processing techniques. We compared, and you can see the accuracy here. This is the example. And the last one is the application of the artificial neural network to the riser structures, top right here. And this is the data processing technique, the procedure. I can't explain all the details within this time frame, but data generations and training is important, and data processing by the Octave or the Python, whatever it is we can do that. And after that, we need to compare those two sets. So this is simple ANN training examples for the riser structures. And we compare the outcomes. It was not that much bad, and we tried to put more input, like 20,000 cases of the riser structures. And you can see here the software result and our ANN result is not bad, isn't it? So that's all for me today, and thank you very much for your kind attention. If you are interested or you have any questions, you can feel free to contact me here by email address. So thank you very much.